Assalamu alaikum. We are going to do some review about final exam calculus 1. Let's start with the first question. Here they ask me to find the following limit. So they ask us to show the work. So first thing, when you do the limit, always substitute the value of the limit into the function. So here it's become 1 squared plus 1 minus 2 over 1 squared minus 4 times 1 plus 3. So here it's become 2 minus 2 over 4 minus 4, which is 0 over 0. So here you have a lot of choice. Either you factor and you simplify, then you do the limit, or you do the L'Hopital rule. So in both cases, you will end up having the same answer. So if I want to factor, so I will have the limit when x go to 1, x plus 2 times x minus 1 over x minus 1 times x minus 3. So now I cancel this, so it's going to be the limit of x plus 2 over x minus 3 when x goes to 1. So here I will end up, I substitute 1 here, so it's going to be 1 plus 2 over 1 minus 3. So it's going to be 3 over minus 2, which is minus 3 half. So if you want to use L'Hopital rules, so here I have to do the derivative of the top, so it's going to be the limit of 2x plus 1 over 2x minus 4 when x goes to 1. Now I substitute 1 into the expression, so it's going to be 2 times 1 plus 1 over 2 times 1 minus 4. So it's going to be 2 plus 1 over 2 minus 4, which is 3 over minus 2 minus 3 half. As you see, same thing. So either you use L'Hopital rule or you factor, you will get the same answer. Next question. So here when we have the limit at the infinite, so when we plug in the infinite, so we will have it's going to be infinite over infinite. Again, you can use L'Hopital rule twice here if you want, or what you do is like take the highest power. So either we take the highest power of the numerator and the denominator. So either I do the limit of 9x squared plus 4x minus 2 over 5 plus 7x plus 6x squared when x goes to infinite is the same thing as the limit of the highest power of the numerator over the highest power of the denominator when x goes to infinite. Then what I do next, I cancel x squared. Then I will end up having 9 over 6, which is 3 half. Or what you do, you take the highest power as common factor. So some professors like to see that way. So we take x squared as common factor. So it's going to be 9 plus 4 over x minus 2 over x squared. And here will be x squared again, 5 over x squared plus 7 over x plus 6. So those, when x go to infinity, is going to go to 0. So this is go to 0, this is go to 0, this is go to 0. This cancel out. What's left is 9 over 6, which is again 3 half. So that's the idea. For L'Hopital rule, you have to do the derivative twice because you will end up having infinite over infinite again. After you do the first derivative, you're going to end up having infinite over infinite. Then you have to do a second derivative to get the answer. So let me show you the L'Hopital rule. So we have limit. Here I take derivative of the first one. So it's going to be 18x plus 4 over 7 plus 12x when x go to infinite. So when I apply infinite here, I will end up having infinite over infinite. So again, I do the limit of I have to take derivative of the top over the derivative of the bottom. So it's going to be the limit of 18 over 12 when x go to infinite. So if I divide by 3, by divide by 6 here, I will end up having 3 over 2, and as you see, it's the same thing. So it's better to use one of those way. It's better than the L'Hopital rule. All right, so let's next one. So here I'm going to use this property, limit when x go to 0 of ax over ax is 1. So here I have limit sine 5x over 2x when x go to 0. I don't have 5x here, so what I do, I write down like this form over x times 1 over 2. So what I do next, I multiply here by 5, and here I multiply here by 5. So, and here will be when x go to 0. So I know that this is 1, so the limit of this will go to 1. So what's left is 5 half, so it's going to be just 5 half. For that type of question, so you have to notice that this is the same thing as the limit when h go to 0. Don't try to do the L'Hopital rule because it's not worth it. You just need to notice that this is the definition of the derivative. So it's the same thing as sine pi over 4 plus h minus sine of pi over 4 over h. So you see this is the definition of the derivative, which is going to be the sine prime of pi over 4, and we know that the derivative of sine is cosine. So what is the cosine pi over 4 is a square root of 2 over 2. So this is what you should notice. Next, so here they ask me to use the definition of the derivative to find the derivative of this function. So we know that the limit of f of x plus h minus f of x over h when h go to 0 is f prime of x. So uh, f prime, which is square root of x prime, square root of x prime will be the limit of square root of x plus h minus square root of x over h when h go to 0. So here I multiply both sides by the conjugate of the numerator, so it's going to be square root of x plus h plus square root of x over square root of x plus h plus square root of x. So here I'm going to use this property a minus b times a plus b is a square minus b square, and we know that square root of something square is just the same thing, so this is the concept I'm going to use here. So it's going to be the limit when h go to 0 of square root of x plus h square minus square root of x square over h times square root of x plus h plus square root of x. Here is the same thing as the limit of x plus h minus x over h times x plus h square root plus square root of x. H 0 of 1 over square root of x plus h plus square root of x plus square root of x, which is 1 to square root of x, and this is the derivative of function. Next question here, they ask me to find out the dy over dx, which is the derivative of the simplified. So I just need to do the derivative only. So here it's This is the same thing as x to the 4 plus 4x minus 1 plus cosine hyperbolic of x minus secant of x. So y prime will be equal 4x cubed minus 4x minus 2. Cosine hyperbolic is sine hyperbolic minus secant, so it's going to be secant tan, so it's going to be minus secant x tan x. So this is for this question. Next question, what do we have? We have to take derivative of this. So here I have product rule. So f g prime is f prime g plus f g prime, and e to the something prime is the derivative of that thing times e of the same thing. So this is what I'm going to use first. So I have y prime will be, I'm going to apply the product rule first. So it's going to be e to the x square prime ln of x plus e to the x square times ln of x prime. So here is going to be 2x e to the x square ln of x, and the derivative of ln is 1 over x, so it's going to be just e to the x squared times 1 over x. So it's you can do it like this way: ex squared times 2x ln of x plus 1 over x. If you take e to the x squared as common factor, you can leave it like that if you want, because they don't ask to simplify it. So here I'm going to use power rule, which is fn prime is n f prime fn minus 1, and I'm using the derivative of tangent of something prime is the thing's prime times secant squared of that thing. So y prime will be, first I will apply the power rule, so it's going to be 2 tangent of square root of x prime times tangent of square root of x. 2 minus 1 is just 1. Now I do the derivative of tangent, which is 2 square root of x prime secant square root of x tangent square root of x. This is secant square because this is derivative of tangent. Now I take derivative of square root, so it's going to be 2, because we just definition can square root of x tangent square root of x, so cancel the 2. Multiply both sides of x. In that case, we do square root on the denominator. So we end up having square root of x over secant square. Next question. Here I'm going to use cos minus fg prime over square. So y prime will be x prime times square root of 4 plus x squared minus x times square root of 4 plus x squared prime over square root of all x square, so it's going to be just 4 plus x squared. Now here this is just 1, so it's going to be just square root of 4 plus x squared minus, here I'm going to use chain rule, so it's going to be x times 1 half 4 plus x squared prime times 4 plus x squared minus half. So the whole thing over 4 plus x squared. So here is going to be just square root of 4 plus x square minus, and here is going to be just x over 2 times 2x, 4 plus x squared to the minus half, the whole thing over 4 plus x squared. So I cancel this, so it will be x squared, 4 plus x squared square root minus x squared, 4 plus x squared to the minus half over 4 plus x squared. So this will be your final answer. So if you want me to show you how I did this, so I did the same thing how I got this. This is power rule because the same thing as 4 plus x squared to the half prime. So I use this property fn prime, which is n f prime fn minus 1. So it's going to be just n is half, 4 plus and half. So now do the next question. So here for that question you have two choices. You change this f of x to the power u of x is e to the u of x ln of f of x. You can use this notation, or you can use ln to do the derivative. So let me do both, and you're gonna see the idea how it work in both case, and we'll get the same answer in both case. So I want to do it first with that way. So we have y equal e x prime, same thing rule. So it's going to be n of x plus x times 1 over x times this will be derivative. If I want to use ln, so I have y equal, so I use the property of n. We all move the exponent down, so it's going to be n of a. So here it become this is n of y. Now is the function, so the function does not disappear. So here we have x prime, which is 1, so by y, you got y prime equals, so y is x to the power x, and as you see is the same of this. So keep in mind integral of u x v dt. Let's take the derivative, so it will be v prime of x times f of v of x minus u prime of x times f u of x. Keep in mind this. Let me apply this here. My v of x is x cubed, my u of x is 1, so I will take y prime will be the integral of 1 x cubed e to the t square dt prime. So this is my v, so it's going to be x cubed prime, and this is my function. So you see it's going to be e to the x cubed square minus 1 prime e to the 1 square. We know that 1 prime is 0, so this will be gone. So what's left is 3x squared e to the x to the power 6, because x to the n we multiply the exponent. So this is will be your answer. So for the next question, so here we have y is defined implicitly, so they ask me to find out y prime. So what I do here, I take derivative both sides, and here I'm going to use the chain rule of sine, and here I'm going to use product rule, so I take derivative both sides. So it's going to be x prime y plus x y prime equal x plus y prime cosine of x plus y. This is derivative of sine. So sine of something prime is derivative of that thing times cosine of the same thing. Now this is just y plus x y prime plus 1 plus y prime times cosine of x plus y. So I distribute, so I got y, this is equal, sorry, x y prime equal cosine of x plus y prime cosine of x plus y. Now I get all the y prime in one side and the rest on the other side. So I minus x y prime both sides and minus cosine of x plus y both side too. I get y minus cosine of x plus y equal, so y prime cosine of x plus y minus xy prime. Now I take y prime as common here, minus both side by y prime. So we end up in y prime equal y minus cosine of x sine of minus x, and this will be your answer. Now tangent line equations where the curve crosses the x the y-axis. So what does it mean cross the y-axis? Does it mean x equal 0? So at x equals 0, what's going to be my y? So it's going to be f of 0 will be 3 to e to the 4 times 0 minus 3 is 3 times 1 minus 3, which is 0. So I need to find out the tangent line at point 0, 0. So what is the equation of the tangent line? The equation of the tangent line is y equal f prime of x1 times x minus x1 plus f of x1. So my x1 here is 0. So and my f of x1 is 0. So it's become just f prime of 0 times x. So I need to find out what is the derivative of f. So f prime of x will be 12 e to the 4x. Now f prime of 0 is just 12 times e to the 4 times 0, which is just 12 times e to the 0, which is 12 because e to 0 is just 1. So my final answer will be 12x, and this will be your equation or tangent line at the point where the curve crosses the y-axis. The next question. So here we have a word problem. So an airplane is flying at an altitude of 8 miles and pass directly over a radar antenna. So they give you the graph here. When the distance between the radar and plane is 17 miles, which is s equals 17, it is changing at 400 miles per hour. That means the s prime is 400 mile per hour. It's exactly what they mean. That's mean I will have S prime is 400 mile per hour. So this is the rate of change of S. So what is the speed of the plane at that time? So they're looking for X prime. So here I know that this is a right triangle. So which means that a square x squared equal s squared. So I'm using Pythagorean theorem. So here I take the derivative now. So I got 2x x prime equal 2s s prime because both of them depend on time. So I take the derivative in terms of time. So I'm doing d dt. So I'm doing d dt. This is the derivative I'm using. So this is why x prime stays because x prime is a function of time. Now I divide by 2. So I got x prime equal s prime. So I know that s equals 17, but I don't know what is x. So if s equals 17, so I know that 8 square plus x square equals 17 square, which means that x squared equals 17 square minus 8 square. So which means that 17 minus 8 times will be the square. If I take square root of 1, so we'll end up having x equal square root of 9 times 5, 15. So I know that x is 15. So now I got all the s prime over x, which is s is 17, 100 miles per hour. We'll end up 17 times 80 over 3 is mile per hour. This is your x prime. You can do the division 3.33, I think. So, but you can keep it as a fraction. It's still so. Next has 900 meters to enclose a rectangular coral. Is to be divided into 4 subcoral. Here I choose to do it this way. So this is the width and this is the length of the coral. So how many width I have? I have 4 and 4, that's mean 8. So I have 8x plus 5y equal the perimeter. So it's going to be 900. So we know that the area of this is 4xy. Now I cannot take the derivative of the area because they want to maximize the area. When talking about maximum, minimum, always take the derivative of what they ask you, the maximum of what and the minimum of what. Here they ask the maximum of the area, I take the derivative of the area. So, but here I have two variables, so I need to substitute one in terms of the other in order for me to do the derivative because I don't know how to do derivative with two variables. So what I do, I solve for y, so I got minus 8x both sides. So I got 5y equal 900 minus 8x divided by 5. So y will be 180 minus 8 over 5x. I substitute this y here. So this will be 4x times 180 minus 8 fifth x. Now what I do, I take the derivative. So it's going to be 4 times 4 it's not 40, is 4 times 180 minus 8, 5x plus 4x times minus 8 over 5. So here I distribute, going to be 30 over 5. So which is 720 minus the area if equals 0. So prime equal 0 and s of 4. So a prime equals 5x equals 0. 7 equals 64 over 20 times 5 over 2. If I simplify by 8 here, and here I got 50 over 8 is my x. So if I do the division, so this is, we have 40, so 48, so it's going to be 625. So this is going to be the value of x. So the land for x, which is 4 times, it is 225, and the width in my width, because when I substitute 180 minus 180 minus 90, which is 90. So this will be your find the absolute max and absolute min. So in order and keep looking for number local max, local mean in that interval, because if you have a local max or local mean on a closed interval, that local max or local mean is the absolute. So first thing the derivative, then you check the end boundary to see what's left for the other absolute. So first let me take the derivative. So f prime is 3x squared minus 12x. So I take the derivative equals 0. F prime equals 0, which means that 3x squared minus 12x equals 0. X times 3x minus 12 equals 0, which means that x equals 0. 3x minus 12 equals 0. So if I solve this, I get x equal 4. If I add 12 both sides, you see, I got 3x equal 12. Then you divide by 3, you got x equal 4. 4 is not part of the interval, but 0 is part of the interval. So what I do my line. So this is minus 1, this is 2, this is 0. So we know that outside is going to be positive because the coefficient here is positive. You can pick a number, by the way. So if I pick, for example, something less than, you can pick minus 1 and plug in minus 1 here. So you're going to end up having a positive value into the derivative. That means this is going to be positive and here is going to be negative, which means that this is increase, this is decrease. That means this is a local max, which means the absolute max. So absolute max is x at x equals 0, and the y is going to be just y equals 0. When I plug in 0, it's going to be 0. So now I check what is f of minus 1 and f of 2. So f of minus 1 is going to be just minus 1 cubed minus 6 times minus 1, which is minus 1, this is square, minus 6, which is minus 7. And f of 2 is 2 cube minus 6 times 2 square, which is 8 minus 24, which is minus 16. So this is my absolute mean. So absolute mean is at the absolute. So for the next question, and where the function increase and where the function decrease. So for A, to find where the function increase, where the decrease, if this is my derivative, I just need to check where the derivative is positive, where is negative. So this is positive, this is negative. So here the derivative is positive. That means on that interval between minus 3 and 4, the function increase. So between the interval minus 3 and 4, f increase, and north side decrease. So and minus infinite minus 3 union. So I don't think I need to use union here, so I'm going to use just and the interval for infinite f decrease. All right. Now for question B, find the open interval where f is concave up, where f is concave. In that case, I'm concave up, increase from minus infinite till minus 2, minus infinite till minus 2, and f, you see, when the derivative increase, we're talking about concave down. So minus 3, 1, and 3 infinite. And a last question. So find the x-coordinate of the relative max and min. You see here, this is positive. This is increase at minus 3. That means this is relative mean. Here there is no change, it's both sides positive. Here is positive and negative. That means is increase, decrease. That means this is local mean. So the x equal minus 3 is relative mean. X equal 4 is relative max. You can use local max, local mean if you want. Alright, for the next question here, they ask me to integrate. So when you have this type of integration and it has one common denominator, so what you do is just spread the denominator. So it's going to be 2 over t cubed minus 3 over t cubed dt. So simplify 2t cubed minus 3t minus 3 dt. Now you integrate using the regular rule, so it's going to be 2 over 4t 4 minus 3 over minus 2t minus 2. Don't forget the c, because the c it may take off point. So here's become half t to the 4 plus 3 half t to the minus 2 plus c. for the next one, so here I need to simplify it here, make it better. So it's going to be 1/2 plus x to the minus half plus secant square x plus 4 dx. So now I integrate this. So this is the same thing if I add. So it's going to be 1, it's going to be 3/2. So it's going to be 1/3 is 2/3 x to the 3/2 plus minus half plus 1 is half divided by half. So it's going to be just 2x to the half. The antiderivative of secant squared is tangent, so you should know that. And here we have 4x, and don't forget the c. All right, for the next question. So here we need to use substitution. So the best way is, and the most easiest I believe, is choose this expression as u. So u equal square root of x minus 1. So which means that u square is x minus 1. I have x by itself. I need to solve for x here. So that means u square plus 1 is your x. Now what is my dx? So I got x. I know what is this is u. Now I need to find out what is the x. So dx is 2u du. All right. Now I substitute this. So x square root of x minus 1 dx is the same thing as what is my x is u square plus 1. What is square root of x is u. What is the x is 2u du. Now I multiply, so I got u square plus 1 times 2u square du. I distribute u square, so and I put the 2 outside, so it's going to be 2 times u to the 4 plus u square du. Now I integrate, so it's going to be 2 times u to the 5 over 5 plus u cube over 3 plus c. Then substitute back my original, so it's going to be 2 times square of x minus 1 to the power 5 over 5 plus square of x minus 1 cube to the power 3, which over 3 plus c. You can distribute the 2 if you want. It's the same idea. Now here I choose my u is sine of t. Why? Because if I take the derivative of sine, give me cosine. So which means that when I substitute by u, the cosine will disappear with the t. So this is exactly what I'm looking for. So du will be cosine of t dt. Now I substitute my information. So here cosine dt is du and sine is u, so u to the 5. Now what I do now, I just integrate u to the minus 5 du, which is minus 1 over 4 u to the minus 4 plus c. Substitute u by its value, which is minus 1 over 4 sine to the you can see a fraction. So next here again I'm going to use my ln of my u. Dx over x is going to be my du. So now this is straightforward. So ln of x ln of x times dx over x is the same thing as u times du, because this is du, and this is just half u square plus c. Substitute u by its value, ln of x square plus c. So this is straightforward. Now let's evaluate this integral. So here I will choose my u is x squared, because if I take the derivative of x squared, give me 2x, which is just x. I can multiply here by 2 and here by half in order for me to get the derivative of the inside. So here du will be 2x dx. I don't have to, so what we do, we divide both sides by 2. So which means that du over 2 will be x dx, and this is exactly what I have, x dx. You see here, x dx, this is what I have. So now I need to substitute, but when I substitute, you see, when you substitute, you need to change the boundary. This is the lower bound, 0. That means x start from 0. I'm going to see what y start, u start from. U start from 0 square. What is 0 square is 0, so I just put 0 here. X and, which is the upper bound, are square root of pi. So I substitute square root of pi here, it gives me just pi. That means u and at pi. Now I substitute, so sine of u and dx will be du over 2. Now I put half outside, so it's going to be between 0 and pi, and sine u du. So what is the entire derivative of sine is negative cosine, so it's going to be half negative cosine of u 0 pi. Now I just substitute, so it's going to be negative cosine of pi minus cosine of 0, which is oh, here I have minus become positive because it's minus cosine of 0. So it's going to be half of minus 1 plus 1, which is going to be just half of 2, which is 1. So keep in mind, let me write it down here. It's to make it clear. So it's going to be minus cosine of pi minus cosine of 0, because here is my natural derivative. So this is how you should do it. This is where we got here cosine plus cosine of 0. Now, next we have here x 3 is positive when x minus 3 is negative. We know that if something is positive, if that thing is negative. So to know when it's positive or negative, I have to know n equal to 0, because I know on the left side of 0 is x equal 3, which means the right side of 3 is positive. This is positive, and the left side, on the left side, I will have negative, and this means this is x minus 3 is less than 0, x minus 3 greater than 0. Once x up to the value of x minus 3, x will be equal to 0, 3. Absolute value of x that it's negative, so it's going to be minus the inside, so it's going to be between 0 and 3, minus 3 x minus 3, which is 3 minus x dx, and this is positive, so it's positive, so which means it's going to be just x minus 3 dx. Now I integrate, so it's going to be 3x minus x squared over 2 between 0 and 3, plus x squared over 2 minus 3x between 3 and 6. Now I evaluate each expression to see what's going to be my final value. So when I plug in 3 here, I get 9 minus 9 over 2 minus 0. This is just 0, 0 plus. Then here I will have 36 over 2 minus 18 minus 9 over 2 minus 9. Now I have uh, so this is 18 minus 18 is 0, so this is 0, and I have 9 minus 9 over 2 minus 9 over 2 plus 9. So minus 9 half, 9 half. When you add it, it's going to be minus 9. So this will cancel out. What's left is just 9. And this will be my final answer for that integral. Now I want to integrate this expression. So here, this is a simple expression. So the antiderivative of 1 over x is ln of x minus x squared over 2 between 1 and 2. So now I substitute the 2, so it's going to be ln of 2 minus 2 squared, which is 4 over 2, minus, and we have ln of 1 minus 1 over 2. Ln of 1 is just 0. This is going to be ln of 2 minus 2, minus 0 minus half, so it's going to be plus half, so which means that my answer will be ln of 2 minus 3 half, and this will be your final answer. Now I need to find out the area of that curve, but here I have an intersection point. That means the area here, the line is above the quadratic, and here the quadratic is above the line. So that means we have two different setup. So to see where the setup change the sign. So here I need to make those two expressions equal each other. So first thing I need to make x squared equal x, which means that x squared minus x equals 0. X times x minus 1 equals 0, which means that x equals 0, or x minus 1 equals 0, which means that x equals 1. So I cannot have 0, but I have 1. So that means that point here is 1. So which means that I have the integral change from 0 to 1 and 1 to 3. So from 0 to 1 we have the line is above the quadratic, and from 1 to 3 the quadratic is above the line. So this is how we set up the integral. From 0 to 1 we have x minus x squared dx plus, and here we have from 1 to 3 we have x squared minus x dx. Now I integrate this, it's going to be x squared over 2 minus x cubed over 3, 0, 1, plus, and we have x squared x cubed over 3 minus x squared over 2 from 1 to 3. So now what we do, we just need to substitute and see what we will get. So here let me have small space, so it's going to be just half minus third 0, so we are going to ignore it because minus 0 just there's no change happens. So here we have 27 over 3 minus 9 over 2 minus 1 over 3 minus half. So here we'll end up having, if I take off the parentheses, it's going to be half minus 1/3 plus 27 over 3 minus 9 half minus 1/3 plus half. So we have half. This is going to be just 9. Half and half is 1, and minus 1/3, it's going to be minus 2/3 minus minus 9 half. So it's going to be just here is 9 half. And 1 minus 2/3 is plus 1 denominator plus 2 over 6, which is 29 over 6. And let's do this question. So velocity. So slope 40 because it's run 1 and rise 40. That means the slope is 40. So that means here the acceleration will be just 40. Just do 40 here. Here it's decreased by minus 40. So from here to here it will be minus 40. And here is increased by 40. So it will be on the same line. It's not going to be just 40. So this is acceleration. So just put here on the middle line and I put acceleration graph. So of course you have to draw it on your paper. Alright, for question B, they asked me for the total distance between 1 and 4, which means they asked me to find out the area because this is the velocity. To find out the distance I need to integrate. I just need to find out the area here and here. So we know that the area of a triangle is base times height. So base is 1 times height is 40. So the area of a triangle is going to be half base height. So here we have the base is 1 and the height is 40. So it's going to be just half 1 times 40, which is 20. For that area here, uh, for the second area, 1, 2, is half base times height. So it's going to be half. The base is 2, the height is 40, so it's going to be 40. So the total distance when I add is going to be just 60. So this is the total distance. So this is my question B. For question C, for the distance, A1 mean that the displacement is 40, which here this is. So I hope you got the idea how the Gaussian calculus 1 works. So thank you for watching the video, and please if you